Hello friends, welcome to FreeCAD tutorial, and in this tutorial we will do modeling and assembly of a C clamp. And as you can see that I have modeled all the parts like a clamp, screw, bar, bush and cap, and I have assembled it, and my assembly view is matching with my isometric view. So to create this assembly, I have used the default assembly workbench, which is very convenient with respect to the A2 Plus and assembly 4. I will model each and every part in this tutorial, and I will show you from the scratch how you can do the modeling as well as assembly. For this, I am using the FreeCAD version 1.0, and it is a release candidate 4. I hope you have installed the latest version of a FreeCAD on your system. If you are a Windows user, then I have already made a video on my YouTube channel how you can run FreeCAD 1.0 on Windows. So I will close this file and create a new file, and I will show you from the scratch. You can also visit my website mechnexus.com, where I write articles and tutorials on FreeCAD. You can download my tutorial source file from here, tutorial source file page, and you can also support me by buying a cup of coffee on ko-fi.com. Your small support will help these channels to grow, and it will motivate me to create more awesome content on FreeCAD. I thanks to all my supporter, those who have supported me by buying a cup of coffee. So keep supporting, and it will help me to grow this channel, and it will motivate me to create more awesome and useful tutorials on FreeCAD. So let's come back to our tutorial. So here I have created a new file, and I will switch to the part design workbench, and here I will create a body and then create a sketch. The first part which we will model is a clamp. So clamp dimension is given here. Now we will start our sketch. So with respect to the orientation of our clamp, so we will select the right plane and create our sketch. So we will select the right plane and say OK. And now here we will read the drawing. So what we will do, we will first create this profile, and we will create this outer profile as a construction. So let's start our sketching. So I will create a rectangle, and I will delete this line, and I will select all this line and make it construction, and provide the fillet of R30 at these locations and these locations. So now click on the fillet, provide the fillet here and here, and I will select this line and this point and make it coincidence. And now I will make it this and this point symmetric. So first give the radius of 30, and this one also 30, and I will use the symmetricity, select this point and this axis, and select a horizontal dimension, and provide the dimension 120, and provide the height which is of 98 mm. Similarly here. So now this is the outer profile which we have made, and now here is a two radius. One is the R30 which we have made, and one is a R10. So what we will do, we will select the polyline tool, and create a rough profile. Now let's give the constraint. So first thing which I will do is to make it a horizontal. Select this and add a horizontal relation. Select this and add a horizontal relation. And now I will create a fillet at all the sides. So click on the fillet, select this and this and this. Now I will merge the center of this radius, merge it. Similarly this and this, merge it. Mm, and this outer one is of 10 mm. Now I will move the dimensions so you can see it. So R5 and R10. And now for the representation purpose we will select a line and close this profile, and do not forget to make it construction. Select these two and make it construction. So here our profile is fully constrained. If you see here, so this is the 8 mm and this outer one is of a 20 mm. So if we see in a model here, so that will be maximum of the 20 mm, which is a maximum dimension. So select the sketch, click on the pad, provide the 20 mm and never forget to make it symmetric to the plane. Click on OK. And now let's move to the isometric view. So we can see here the fillet. If we go in a drawing, so here is a R10 fillet is there. So we will select this edge and click on the fillet and provide the fillet of 9.999. Now we will create this pad here. So for this we will select the face and click on the sketch. Click on the project geometry, project one of the radius, and select line tool, project the edges and then create a line. So select a line tool, draw one line here, one line here, and create a 3-point arc. Select this point and this one, and select a line tool and provide the horizontal dimension. And now I will fix this length. Select a smart dimension, select this point and provide it 23. Click on close, and now create a pad of 20 mm. Click on close it, select the pad and provide 20 mm. Click on OK. And now we will create this mid feature. If we see in a right view, which is of 8 mm thickness, so we will on our origin plane, and we have the plane as a center, which is a YZ plane. So we will select this YZ plane and click on the sketch and hide our origin plane. And now First I will use the project geometry, project this edge, this edge, this edge, this edge, this one and this one. So better to place our model at a wireframe so that we can see our projected line. Now we will create a exact line and arc with respect to our projection. So select the line tool, select this and this, and select a 3-point arc, select the line tool, select this and select a 3-point arc. So rotate our model. If you are facing difficulty, you can also create a sketch in a isometric view, but I prefer in a normal to the my screen so that I can pick the point easily. Now we will rotate it and let's see what is unconstrained. So this is the unconstrained. Because it is not equal, apply the equal constraint. Similarly here, let's find out, here is also same issue. So we have created a profile with respect to our projected geometry, and now again we will select a line tool, and make it horizontal, and we will create a fillet on both the sides. So click on the fillet, select this and this, this and this, and now select this and this and add a coincidence. So here it is some issue. Now let's select this and this and add a coincidence. Yes, so let's move to the nearby and select this and this and add a coincidence. Yes, so you can see that our profile is fully constrained, and we will switch to the flat lines, and this rib, or we can say that this features, which is seems to be like a plate having the thickness of 8 mm. So select the sketch, and we will move to the pad options to create a pad. So select the sketch, click on the pad, give the 8 mm and make it symmetric to the plane. Click on OK, and here we have created overall shape of the clamp. And now move to the next feature. Our next feature is to create a hole which is of M12. So we will select the face and click on the sketch, and we will rotate our model, click on project geometry and create a circle of 12 mm. And move to the hole wizard, and from here select isometric regular profile, and in a drop down select M12, and from here select the dimensions 25. No issue, this is the just open to the other side, and click on OK. Now our next feature is to create a cut, which we can also see in here in our 2D drawing. So select the face and click on the sketch, click on project geometry, project this and this, select line tool, select a smart dimension, select this and provide it a 30 mm. Now click on close and click on cut and say here through all, say OK. So here we have created a model of a clamp, and let's apply the color. So select the last feature and click on appearances, and here click on the custom references and click on diffuse color, and let's select the color, click on close. So here we have created a model of a clamp. Now we will create a model of this screw. Now we will create this screw, and if we see in assembly, so this is our screw. So here I have inserted my body and activated the part design workbench, and now I will switch to the right plane and create our sketch. Go to the model tab and hide it, and now I will select a polyline from here. Select it and add a vertical, and now we will give the dimension. Select the dimension tool, this is 3 mm and this is the 6 mm, and total length is of 130, which we can see here. So provide the 130, and this is of 22, and this diameter of 20, so provide the radius of 10 mm, and this is of 12 mm. So this is a very simple part, this our screw, which we will made with a single revolution. So come out of the sketch, select the revolve tool and select reference and revolve around to the y-axis, click on OK. So our base feature is created, and now we will create the hole, because this bar will insert here. So we will set our model to the isometric, and we will on our plane and select this plane and click on the sketch, and from here I will switch to the wireframe, and let's hide the datum plane. And now here I will create the circle of 5.5, and I will project this edge, select smart dimension, select this and this, and provide the 12 mm, and we will come out of the sketch, and from here we will switch to the flat lines, select the sketch, and we will click on the cut and we will make it through wall and keep it symmetric to the plane, so our hole will become through. Now let's move to the next feature, which is to provide some approximate color. And here if we see our screw, so here it is a M12 thread, and if we go in our model, so we have provided this diameter 12. So I have a macro called a Cosmetic Thread. I will go to the macro and let's execute it and select it. Cosmetic thread. So you can see that a cosmetic thread is inserted, even though this is not very perfect. So I hope in our upcoming release some cosmetic thread options will come like SolidWorks. As of now I will delete it, and let's give color. So here let's apply it chrome because it is shiny, and from custom appearance click on OK, click on close. Now we will model our next part, which is a bar. So I will save it as a screw. Here I have save my part as a screw. Click on save, and let's model this bar. So I will close it, and I will go to the new file and insert my body, and on the origin plane, and here it is a very simple part, so I will select the right plane and click on the sketch, go to the model tab and hide it, and it is of a 96 of a diameter 5, so give it a 2.5, and this is of a 96. Now close it. I will revolve it and revolve around to the y-axis. Click on OK. So if we see our model, so this is the bar, so we will provide some minor entry chamfer. Let's give it 0.5. Click on OK. Now I will save it. I give the name. Now I will close it, and let's move to the next part, which is to create this bush. So here I will create a new file again and insert my body on the origin plane. So here I will select the right plane again and click on the sketch, go to the model tab and hide the origin plane. So here I will select a polyline tool and create a rough profile. So this is our basic profile, and now we will constrain it with the dimension, but here I will create as it is with respect to our 2D view, because here is a flat face of 2 mm. So now let's give the dimensions. Select the dimension tool, and this is of 2 mm, and this to this center. So radius will be the 7 mm because it is a 14. And now I will move it and provide this one as a horizontal. Overall it is 20, so from here to here it will be 10, and let's move it, and it is a 11 mm, so it will be 5.5. select this and provide 5.5. so here it is a 2 mm and outer one is of a 3 mm, so I will make it 3 mm, and let's move the dimension, and again select the dimension tool, select this, and it is of a diameter 7.6, so it will be 7.6 divided by 2, and let's define the overall length, which is of a 16 mm, which we can see here. So let's cross check all the dimensions. So we have provided the 14, our radius is of a 7, 7.6, 16, everything is correct, and our sketch is also fully constrained. So we will come out of the sketch. Now select the revolve, and from here we will select the y-axis and click on OK. So here we have made this bush, and let's apply the color. Switch to the isometric and go to the appearances, and from here I will select the chrome because it is shiny, and from here let's select some different color for this part. Let's see how it is look. Okay, now I will close it and I will save it as a bush. So click on save. Here I will put the push underscore R1, and now the next feature we will create is a cap, which is a very simple part. So here if you see, this is the 4 number is of a cap. Now let's close the current file and create a new file, and we will insert the body, and on the origin plane, and we will select this right plane and click on the sketch, go to the model tab and hide the origin plane. And now here I will again select the polyline and create a rough profile. So we have created a rough profile. Now let's give the dimension. Select smart dimension, and inner one of the 6, overall length is of 9, and this is of a diameter 5. So from here to here it is of 2.5, and outer one is of 4 mm. And let's move it to the inside. Now here we can see inner diameter is of the 5 mm and this is the 6, and we have to define this one here. So here if you see it is a close, so we will select this arc and our origin point and make it a coincidence. Let's move the dimension. Now select this line and this and add a coincidence relation. Now we will close it and we will revolve it, and from here select y-axis, click on OK. So here is a 8 mm, it is a 7 mm, means 0.5 chamfer. So provide the chamfer, click on OK, and here is our cap is completed. Let's give some random color and click on save. So we have created all 4 models. Now we will start our assembly. Now we will create the assembly, as we have created the model of a clamp, screw, bar, cap and bush. And here I have created new file, and I will first save this file. So here I have save my files, and I will use the default workbench. So I will switch to the assembly, and here you will see that tools are different with respect to the assembly 4 and A2 plus. So here first option is that create a assembly. So here I have inserted the assembly. Now here is the options to import component, and click on open file, and first component which will be insert is a clamp. Now select this body, and here it is asking whether you want to the first grounded part, your first part will be the get grounded, so I want yes, click on OK. So as my first part is a grounded, so you can see here the lock symbol, and if you go here under the joints you will find that a grounded point, and you can hide it if you do not like it. And now the second component which will be insert is the screw. So click on insert component, click on open file, and we will insert our screw. Here screw is inserted, select the body, click on OK. And now here it is inserted at a body, so I will select it and press F2, rename it, and I will give it a clamp, and press F2 and give it a screw, and I will refresh it. Now I will use the transform tool, click on OK. Now I will insert my screw in this clamp. So here you can see the icons are inactive because I have not activated my assembly. So click on the active object, now it is activated. Now here we have the multiple options, so we will use this create a cylindrical joints. So I will select this and this by pressing the control key and click on this constraint. So you can see that it is inserted, and here is also option of a flip, but I want as it is. Click on OK. Now I will short my browser here and update it. Now I will click on the transform, and I will rotate my model little bit. Click on OK. Now I will on the origin plane of my screw, and here I will place it as a isometric, and now I will on the origin plane of the assembly. Now I will select this, and I will apply the parallel constraint. So here my body is not active, so first I will activate it, and now I will select this plane and this plane, and here is a parallel joint, and click on OK. So best thing about this new assembly workbench is that we can give constraint with respect to the plane to plane. And now here I will off the origin plane, and here distance is not that much important, but to fix my part, to fully constrain my part, I do not want any degree of freedom should be left. So I will select this face and this face of my screw, and here is a distance constraint, and here I will give some approximate distance, let's say 20 mm, or give 40, and I will set it to the isometric. Now I will insert this 5 number part. So I will go in insert, click on the open, and here is my bush. Now I will rename it. Now I will move my bush to the outside of the body, and now here I will press the control key, and first I will select this inner cylindrical face and this one, and here first I will activate it, select this and this, and apply the same constraint, cylindrical joints, and click on OK. Now we will use the transform tool to move little bit outside. Now select this face and this face, and we will apply the constraint. Select this, and here we will use the distance joint, and we will keep the distance 0. Now let's switch to the isometric view. Now we will insert this bar, which is item number 3. So I will go in insert component, click on open file, and we will go to the bar and insert it. So here is my bar which is inserted here. Click on OK. Now I will give it a name by pressing the F2 and give it bar, and let's collapse it. Now I will use the transform tool to set my bar in the position. Actually it doesn't matter, but it is my practice. Activate the assembly and press the control key, select this and this and use the cylindrical constraint. Click on OK. Now switch to this view and let's give some distance constraint, approximate distance. So use the distance and let's give it 35 mm or 45. Yes, it is looking symmetric from both the sides. Now switch to the isometric and now we will insert the two caps. Now click to the insert, click on open file, and here is the cap, and where it is inserted, so cap is here. Click on body, insert it is, and rename it to the cap, move it outside and also rotate it. Now select this and we will use this constraint, but we will activate our assembly and let's select this inner surface, and we will say OK, and now we will move it. Let's see it is a reverse or yes, so we will reverse it. So now we will go to the assembly and go to the joints, and this is the cylindrical joint, and here we will flip it. Click on OK. Now we will move our cap to the outside, select this, and here we will provide a distance constraint. So you can see that it got assembled. Now again click on insert and click on the cap. So one more cap is inserted, give it a name, again cap. Now I will move it to the outside of a body, and now here we will transform. First activate the assembly and click on this cap and rotate it. And now here what we will do, first we will select this inner face, select this inner face and this face, and here we will use the distance mate and give it 0. Click on OK, and here we will use this distance mate and we will flip it, and you can see that it got perfectly made. Here we have reduced one constraint which is of a cylindrical constraint. So now if we switch to the isometric view, as you can see that my assembly view is matching with the isometric view, and we have used the assembly workbench, which is more convenient than A2 plus and assembly 4. In future I will make a more assembly tutorial to get familiar with the other constraint type of a tool of a default assembly workbench. So this is all about this tutorial. Thank you for watching and thank you for your valuable time.